Hey, it's Miss Leave again. I was going to talk about factoring by grouping. It's sometimes useful when you cannot factor. If you have a trinomial like this, it's usually better to use the x method that I've done before. But if you have other things like these examples, you can't really use the x method. It's not a trinomial. So factor by grouping can help in this kind of sense. So I first want to talk about why it works. And if you think about if you were to actually FOIL or distribute. So here I have x times x. So I'm distributing this x times both of those things. And then I would be distributing this -3 times both of these things. So in essence, when I FOIL or when I distribute, I end up saying that I want this x right here, and I want it to get multiplied by this x minus 2. And you might see someone break it out like that when they're showing you the work for it. And then I want this -3 times this x minus 2. So really I have an x times the quantity in the back, and the -3 times the quantity in the back. Well, you also might see that written like this. So I wanted to show you this way of looking at the distributive property before I showed you the splitting the middle and factor by grouping. So you can kind of see when we make the step to go from here to here, where this is coming from. If I'm multiplying things on the outside by that same exact thing, it's because I've essentially distributed something in parentheses to that thing. So let me use this example to kind of show you where those were coming from. So on this one, I have to split this middle, and really I'm looking for numbers that would multiply to 6 and would add up to a -5. And in order for me to get a negative, I have to have a negative in here somewhere. So that means I need 2 negative numbers. And with 6, I either have 1 and 6 or 2 and 3. If I had 1 and 6, I'll go ahead and write that. So I have 1 times 6 and 2 times 3. If I had 1 times 6, the only possibility of getting a 5 would be if I subtracted. But if I subtracted, that means that these two numbers are opposite signs. One would be positive and one would be negative. And if I multiplied them together, if one of them is negative, I would get a negative result. And this is positive, so I know I cannot use that. I have to use the 2 and the 3. So I need the 2 and the 3, and they both need to be negative. And they have an x, so they both need to be like that. I'm not changing this x squared, and I'm not changing this 6. Now essentially, I'm going to kind of do what happened over here. I'm going to group these two together, and I want to group these two together. So if I think about that separately, I want to think, what do these have in common? Because that's really kind of what factoring is. I'm undistributing it, right? I'm doing the reverse. So if I cover that up, I want the sign of this to stay with the thing on the right side, because the sign stays in front of the number. So I'm covering that up. I'm looking at just these first two terms. I want to know, what do they have in common? Well, these two have an x in common. So I'm going to pull that x out front. And then whatever's left over, x times what would give me x squared, or I could divide x squared by x. Either I'm going to get an x. And then if I divide this by x, I end up with just a -2. And if I look, essentially, if I were to redistribute this, x times x is x squared and x times negative 2 is negative 2x. For this next part, I want to figure out what these two things have in common. Well, it looks like they both have a 3 in common. So I could just divide them by 3. But if I did that, I would get a negative x right here. And I kind of want this to match with that. So in order for me to do that, I'm going to need x to be positive. So the only way for me to get this term right here to be positive is if I divide it by a negative number. So I'm going to divide both of those things by a negative 3. If I divide this by negative 3, I get that positive x. And if I divide a positive 6 by a negative 3, I'm going to get a negative 2. And now if you look, both of those terms in the parentheses now match each other. And that's exactly what we did over here. So I'm going to rewrite this in my head knowing that I could have achieved this from distributing. So then, whatever these two terms are out front, you put those together. And then whatever the thing was that was the same, that was already in these parentheses, right? Whatever this thing that was the same is, that's going to go next to it. So now that I've talked through a good example, let's go through some more of them. So luckily on this first one, I don't have to split the middle. It's already 4 terms. And I want to cover the last 2 up, look at just the first 2 terms, and ask what do they have in common? Can I pull anything out? And I can. They both, if I look at just the coefficients first, they both have a 2 in common, so I'm going to pull the 2 out. And they also both share a u in common. Now, this, what I'm doing right here, is essentially pulling the GCF out of the first 2 terms. That's what I'm doing. And then on the inside I say what's left over. So I would need a u plus 2v. And then when I go to look at my next side, this already says u plus 2v. So what could I multiply this second half by in order for it to stay exactly the same? Well, I could write plus 1 times u plus 2v. And then if I have a 1 here, it doesn't change what is over here, and I still represent that if I'm distributing, I have that placeholder, right? That'll give me 4 terms. If I just ignore it, I won't have those 4 terms. Now I put them together. So the first 2 terms come together, 2u plus 1. And then the second terms come together. And that is my answer. So the process was grouping, kind of factoring by grouping. I grouped the first 2 terms together, and I grouped the second 2 terms together, and then factored out the GCF. And then the end result is that I now have a factored form. I can do a lot more with that later. So on this next one, again, I want to look, and I want to look at the first 2 terms, and I think it does have anything in common. And if ever you look at these first 2 terms and they don't have something in common, if the 2 middle terms have that same backpack, have that same ending, all the same variables with all the same exponents, So these both have just x's. You could sort of switch them around to see if maybe that helps you. I'll show you on this last problem here how to work that a little better. So for now, I want to cover those last two up and look at just the first two. I'm just grouping those first two together. And on this problem, I'll show you. Sometimes they put parentheses to kind of say I'm just looking at the first two or I'm just looking at the second two. So for this first one, they have a 5 in common, and they both share an x. So I'm going to pull out a 5x. And what's left over is x minus, and 30 divided by 5 is 6. And then over here, I have a 2x and a 12, and what they both have in common is a 2. So this was a plus, so I'm pulling out that plus 2. And then when I divide 12, this minus 12, when I divide it by 2, I get minus 6. So then when I write all of that together, first, those leading terms in front, the GCFs that I pulled out, they become their own. 5x plus 2. And then the things that they shared in common also gets written just once. So now for some harder, well, C is not harder. In D I want to have a discussion on. So again, I'm putting these first two terms together, thinking about what they have in common. This has 3 x's multiplied together, x times x times x. This has 2 x's multiplied, so they share 2 of those in common. So I'm going to pull out x squared. And what's left over is x plus 1. Because x squared times 1 would give me x squared. So I need that placeholder here to represent that I should have one of those in there. Then, here, if you notice, just like what happened on this first problem, I already have an x plus 1, but I need a placeholder, so I have to say plus 1 times x plus 1. And then whatever these first two terms are, I write those, x squared plus 1. And whatever those secondary terms are, I just write that once. No matter how many times it shows up, these two things are being multiplied to that same one. Remember, it's like we're doing that distributing. I don't write this x minus 1 twice, even though I'm multiplying both of these terms by it. So remember, it only shows up once in here. Okay, so now on this one, I wanted to, in case you haven't seen the other video, in order to figure out what I should be splitting this into, I kind of need to know a lot of things. The best thing I have seen to come up with that is a way to organize by making an x, and on top of the x you put a times c. So this is a trinomial when I have to split the middle. So I have 3 and a negative 12, and when I multiply these two things together, I'm just looking at the outside ones for the trinomial, 3 times negative 12 is a negative 36. And then whatever I didn't use before, whatever's in the middle, I write on bottom. So essentially, in order to split the middle, what I'm looking for is two numbers that could multiply together to get a negative 36, and could add to get a positive 5. So I could start writing them down. 1 times 36. And I want to show you this first. You want to go in order, just in case you miss something. Now I could write 5, but I know that 36 is not divisible by 5. So to showcase, if I take 36 and I don't know what let's pretend I don't know what it is if I divide it by 2. You can really think about this as two numbers. This is 30 plus 6. So 30 plus 6, if I divide 30 in half, I get 15. And if I divide 6 in half, I get 3. So if I take those, 15 plus 3 is 18. So 2 times 18 would give me that 36. So I kind of broke 36 out into two separate pieces, a 30 plus 6. And I cut each of those in half and then added the halves together to come back to the whole. If I divide it in threes, luckily these are both divisible by 3. So it's what number 3 times would give me that. We'd get a 12. And then 4, I would get a 9. I would say 5, and then 5, I would either have a 35 or a 40, so I know 5 doesn't work. 6 times 6, and then I would go to 7 and 8, and none of those work, and then 9, and I've already used 9, so those are all of my possible candidates. So I want to find one of them that could give me a 5. And because I have a negative on top, that tells me that my signs here are different. One of them is positive and one of them is negative. So I'm looking for two numbers that when I subtract them could give me a 5 difference. This is a 35 difference. This is a 16. If I subtract these, I get 9. If I subtract these, I get 5. So that's really the pair I'm looking for. So I'm splitting this 5 into two things. My rule of thumb that I said before was my bigger number has to match the sign at the bottom. So 9 is bigger, so 9 is positive, and my 4 is negative. So this 5x gets split into a 4x and a, let's say, a negative 4x and a positive 9x. And I wrote it like this for a particular reason. Let me group them and see what I can do. So if I look at these first two terms, I have a 3 and I have a 4. So the coefficients don't match, but I could pull an x out and I end up with 3x plus, sorry about that, 3x minus 4. And then I want to do something similar on the right side. So I have a 9 and a 12, and they both have a 3 in common, so I'm going to pull out a 3 and end up with 3x minus 4. And if you notice, my back halves now match. So my end result is that I have x plus 3, those are my fronts, and then whatever I had in my parentheses, 3x minus 4. Now if I show you the other way, I always like to pretend like we're going to go to imagination land. So we have finished that problem, but just in case you worry about when these are written, sometimes you might have to flip them, sometimes it would work either way. So if I wrote it 3x squared, and if I just happen to have written them down this way, plus 9x, and then minus 4x minus 12, would I still get the same result? So just like before, I want to look at those first two terms. I have a 3x squared and a 9x. Well, the 3 and the 9 have a 3 in common, and they both have an x still. So I'm going to pull out 3x, and what's left over is x plus 3. And then I look at the second half, and you see how I see a negative here and a negative there? Well, they both have a negative in common. And I also know that I want the middle term to have a plus. I want these to both be positive, so I need to pull the negative out anyway. So I'm going to pull out a negative 4. So if I divide this by negative 4, I get a positive 1x. And then if I divide negative 12 by negative 4, I get a positive 3. And then lo and behold, just like before, these two pieces I write together as my 3x minus 4, and then the things that they shared in common was x plus 3, and I ended up with the exact same answer I did if I started the other way around. So even if you write that split the middle thing a different way, you should end up with the same result. So I hope this factor by grouping has really helped you. Please remember to share, to like, and to subscribe. Have a great day. Bye.